still have some people anyway. So all right. So to begin with, just give me a minute here, students. There appears to be some technical issue because a lot of students are getting logged out and coming back in the waiting room. Let me just check. Okay, everything seems in order now. Yeah, so let's quickly look at the important concepts we saw last time. Let's go over them quickly. So first of all, we saw that for a given vector, we have something called direction cosines, okay, which are the angles made with respect to the x, y, and z axis. We saw that for any given vector, with three-dimensional components, we saw that the direction cosines are such that cos alpha is x component divided by modulus of the vector, cos beta is y component divided by modulus of the vector, and cos gamma is z component divided by modulus of the vector. Okay, where we saw obviously that any of the direction cosines ranges between 1 and -1, because any of these angles ranges between 0 and 180 degrees. So one thing, then we also saw that if a particular angle happens to be 90 degrees, then that particular direction cosine becomes 0. So then it becomes a two-dimensional vector. For example, in this case, it is in YZ plane, because the x component will be 0. If this is 0, that means the x component of the vector is 0. So that means that it's lying in the YZ plane like that. Then very important property of direction cosines that we saw is that the sum of their squares, cos square alpha plus cos square beta plus cos square gamma, is equal to 1. These were the important aspects about direction cosines. So hope that is clear. Now, of course, in the worksheet, I have also given you some applications of direction cosines we should be discussing, and as I come to those questions, I'll explain that very soon. Okay. All right. Now, the next thing that we saw was scalar product, or what we call dot product. Of two vectors. So we saw that the symbol that is used for the scalar product is this, the dot symbol between the two vectors, and specifically it means magnitude of one vector into magnitude of the other multiplied by And we saw this whole set of properties. So here also, for example, cos theta ranges between -1 and 1. Okay, so for example, if A dot B is positive, it means that theta is acute. If A dot B is 0, it means that they are perpendicular vectors. If A dot B is negative, it means that theta is obtuse. So on and so forth. We saw a whole lot of properties, so I'm not going to get into each one of them again. But properties are fairly obvious, like distributive property, then commutative property, okay, then various things like that. And finally, we saw something important. Finally, we saw that using those properties, we were able to see that, for example, dot product of a vector with itself becomes square of its magnitude. And for example, I cap dot I cap is 1, j cap dot j cap is 1, and so on and so forth. Whereas I cap dot j cap will be 0, or j cap dot k cap will be 0. So that was the relationship of the special unit vectors. Dot product of any unit vector with itself is unity, but with any other perpendicular unit vector becomes 0. So using this and the distributive property, finally we also had the formula of dot product in component form, that is dot product of two vectors becomes product of x components plus product of y components plus product of z components. So this became an important formula for us. And we saw one of the applications that to find the angle between two vectors, we have this very nice method. Okay, the two vectors given in component form. We had this method that cos theta should become equal to A dot B divided by mod A into 1. Where in this you can see in this formula, A dot B just has to be substituted as this formula. Whereas mod A is root of ax square plus ky square plus az square, and similarly mod B is equal. So these kind of things. Okay, so this was the basic recap of the things that we learned. So let us start with some examples from that worksheet that we did. Okay. So just turn to your worksheet and I will take you through some of these examples. Okay, a lot of people have asked me question 1's solution, which I thought would be fairly obvious and direct, but anyway, we'll do it. So question number 1, you have to just find the angle that A plus B makes with the x-axis. Okay. So first question, you were given two vectors. Okay. I'll show you what those vectors is, but all you have to do is you have to find the angle made by E plus B with respect to x-axis. Okay. So what we have to do in this question, we have to just first basically find this vector. We have to find how much this is, and then from that we have to find what this angle is with respect to the x-axis. So we have, for that one, we have to express the direction cosine with respect to x-axis, cos alpha. So given the two vectors, so A was the vector 4i cap minus 2j cap plus 6k cap. whereas B was the vector I cap minus 2j cap minus 3j cap. Okay. So now just do this. Do the steps I'm telling you in case you haven't done this question. Step 1 is find E plus B. Or let's say that becomes a resultant. Okay. And then next step, find this direction cos alpha for the resultant vector. So how we'll find that? That cos alpha will become resultant vector's x component divided by its magnitude. So that's all you have to do in this question. Okay? So I'm just minimizing this, and in case you haven't done this, just try this out directly. ये दोनों वेक्टर्स को ऐड करके रिजल्टेंट निकालना है, उसके बाद रिजल्टेंट का cos अल्फा निकालना है या डायरेक्शन कोसाइन विद द x एक्सिस, that is nothing but x component divided by magnitude of result. So just try this out, people. Should be fairly easy, this one. Okay, people, done. Yeah, very good. So you can see यहाँ पे resultant कितना बन जा रहा है? 4 plus 1 5 I cap minus 2, so that's minus 4 j cap. Okay. And 6 minus 3, so that is 3 k cap. So this is the resultant, and its magnitude will become how much? Square root of magnitude of r will become square root of x square, so that is 5 square, plus y square, so that is 4 square, plus z square, so that is 3 square. So square root of 25 plus 16 plus 9, so that is square root of how much that is? 25 plus 25, so 50 or 5 root. Okay. That's it. So this is becoming how much? 5 upon 5. That's 1 by root 2. Okay. So that's it. So that's your answer. So cos alpha is equal to 5 by root 50 or 1 by root 2. Okay. So you can say alpha is cos inverse 1 by root 2. It's actually how much? It's 45 degrees or 5 by 4. But here the answer is given in cos inverse form. Okay. So we'll leave the answer in this form, which is the same as cos inverse 5 by root 50. Okay. So you have to give the answer according to the format given in the question. So here you can also express this as cos inverse 5 by root 50. So you just leave the answer this way. So that happens in a multiple choice question. The answer may be reduced to the final form, may not be reduced, whatever be the case. Okay. So that's no big deal. Okay. Okay, then next, people seem to have got most of the questions before the 9th question and the 8th question. Does anybody have a doubt before question number 8? Okay, second and third also. Okay, we'll discuss. All right. We'll discuss these questions. Now, second sum is saying that two vectors A and B are given. Now, we have to find a third vector which has the same magnitude of B but is parallel to A. So, find a vector which has magnitude equal to that of B and direction along A. So let's first understand the concept of what we have to do in a question like this. So it's quite easy to find the magnitude of the vector B once it is given. But how do we find that vector which has direction same as another vector? Let's look at this thing here. So how to find which is along another vector C. So for this, I'll just say recall something. Recall this operation C is equal to n into A, where n is just a number. Basically, it's a scalar quantity. Recall this operation, what it gave us. It used to give us a vector such that magnitude of C becomes mod of n times magnitude of A. Okay. And if n is positive, then C is parallel to E. If n is negative, then C becomes opposite or anti-parallel. Very simple. So this concept we use. Okay. So for example, suppose we had a vector which is 2i cap plus 3j cap. And now I ask you find a new vector C such that C is parallel to A. Okay. And magnitude of C is 10 units, suppose. Okay. So what we'll do over here is first we'll see that, okay, what is mod A? Mod A is square root of 2 square plus 3 square. So that is square root of 13. So fine. Now, what I want mod C to be? Mod C should be 10 and C is parallel to A. That means C should be n times A, where n is basically what? 10 divided by root 13. How I know that n is 10 divided by root 13? I know that mod C in the case of a positive number is n times mod A. So यहाँ पे क्या होना चाहिए? Now because C is parallel to A, so that n should be a positive quantity. And once I know it's a positive quantity, now I know that mod. So this is telling me, okay, that because it is parallel, n should be a positive quantity. Now once I know it's a positive quantity, I also know that magnitude of C, which should be 10, should be n times magnitude of A, which is root 13. So that is now telling me what? N should be positive. So in this case, the vector C will just become 10 by root 13 times the vector E, which was 2i cap plus 3j cap. This becomes answer. So just understand this small method first, then we'll come back to the question. How to find a vector which is along another vector. So along another vector means parallel to it. तो उसके लिए हम indirect use करते हैं of this operation, which we discussed earlier. Multiplication of a vector with a scalar quantity. So if we multiplied a vector E with a scalar quantity n or a number n, then what happens? That if n is positive, then the given vector becomes parallel to the original vector E. If n is negative, then it becomes anti-parallel. And also the magnitude of the new vector C becomes n times the magnitude of the vector E, or mod n times in case n is negative. So we make use of this. So through this, now look at this example. I'm given this vector and I want to find this vector. So this will now become like this. Okay. So now you can see, given this vector E, I found a new vector C, which is parallel to A, but it's having a magnitude of 10. If you can do the calculation and check, if you find out mod C, it will come out to be 10. But also you will see that C is a positive number times E. It is 10 by root 13 times E, which means that it is parallel to the vector. Okay, people, so understood this. So now let's go back to that question number 2 and complete it. So in question 2 of your worksheet, just values are given now. You have to properly, so A is the vector 3 I cap plus 4 j cap, and B is the vector 7 I cap plus 24 j cap. Okay, and we have to find a vector, let's say find a new vector C such that the magnitude of this new vector mod C is equal to the magnitude of the vector B, and C is parallel to B. So just work this out quickly. Use the method I just told you. Yes, Smith, your method is correct. You got it right. Aditya, you are correct. Yeah. Yes, Athar, you are also correct. You can also do it that way, that the angle that vector E is making with the x-axis, theta, which in this case is how much? That theta will become 53 degrees. Should be the angle that vector C is also making, but vector C's magnitude should become 25. So there are, yes, so only when is positive, then the two vectors are parallel. Otherwise, the vectors become anti-parallel. If n is negative, then the vectors become anti-parallel. So yeah, it's a good thing. Many of you are proposing some different methods also. So for example, here we can do that also. We can see that vector E is in the xy plane, making an angle of 53 degrees with the x-axis. You can see tan inverse 4 by 3. So vector C should also be the same. But what about the magnitude of vector C? It should be 25. You can see here that mod C should be equal to mod B, should be equal to square root of 7 square plus 24 square. That is square root of 49 plus 49 plus 576. That is square root of 625. So that is 25. Okay. Now we can also, in this case, we can do this question a number of ways. Okay. We can also do like this, that vector A being 3 I cap plus 4 j cap, we can see that it is in the xy plane, okay, at theta equal to tan inverse 4 by 3, or that is 53 degrees with respect to x-axis. Okay. So now a vector C should become such that C's x component is C cos theta and y component is C sin theta. ऐसे भी कर सकते हैं. So you can see that this should be 25 cos 53, and this should become 25 sin 53. You should make this 15 and make this 20. So this is also a method by which we can do. Okay. Or we can do by this method that magnitude of C is 25 and C is parallel to A. Therefore, C should become some n times A, where n just becomes mod C by mod A. So mod C was 25 and mod A was 5. So become 5. Okay. So C should become 5 times 3 I cap plus 4. So this method is also there. Okay. There is one more method of doing this, and we'll discuss that very soon. That is the method of making use of unit vectors. But as of now, you can just understand these two methods. All right, let's move on. Now, third question is very simple, so I'm not going to get into the full discussion. But since few students have asked, so I'll just explain how to do. So in the third question, what you have to do is you have to find the condition for a given vector to be a unit vector. So condition for a given vector, let's say A, to be a unit vector, that condition is just that mod A should be equal to unity, or root of ax square plus ay square plus ez square should be unity, or just square both the sides. So ax square plus ay square plus ez square should be equal to unity. So just apply this condition for that given vector, and you will find the value of the unknown quantity C. Okay. Let's move on to fourth question. This is a direct question, the angle between two vectors. So let's just do this as a practice question. So in question 4, we have two vectors given to us. The vector E is I cap plus j cap, and the vector B is 2 I cap plus 2 k cap.
You have to find theta, the angle between them. So this is a very standard example of that application of dot product. Here we'll use the formula that cos theta is equal to A dot B divided by magnitude of A to magnitude of B. So now from these two vectors, you can see that what should be our A dot B? It should be product of x components, that is 2, plus product of y components, that is 0, plus product of z components, so it should be 2. Okay. Ax bx plus ay by plus az bz. You can see that ax into bx is 1 into 2, ay into by is 1 into 0, and az into bz is 0 into 2. So that's it. Okay. Then you can see mod a should be square root of 1 square plus 1 square, so that is root 2, and mod b should be square root of 2 square plus 2 square, that is 2 root 2, or mod 8, I mean square root of 8. So now your cos theta from this is becoming A dot B, which is 2 divided by this, is becoming 1 by 2, as you can see. So theta is cos inverse half, so that is nothing but 60 degrees. So this is a direct application of the formula for the angle between two vectors using scalar product. So at this point of time, there is no other method of doing this question. क्योंकि दोनों वेक्टर को हम ड्रॉ नहीं कर सकते हैं. One is lying in the xy plane, the other is lying in the xz plane. So they are three-dimensional vectors. Had they both been in xy plane, then we could have gone ahead with the other method we've seen also. Okay, fifth question, fairly straightforward. Again, I'm not going to do the full thing, but you can just write F1, the three forces acting in mutually perpendicular directions. So just assume one is along the x-axis, the other is along the y-axis, and the third, because it's perpendicular, is along the z-axis. So 12 k cap. And now all you have to do is you have to find mod of F1 plus F2 plus F3. So just use the formula for mod and you will get the answer. Okay, sixth is a question where now question 6 type of questions, they become a little bit more lengthy because what you have to do is you have to check the options. It's not directly asking you to do some operation, but it's just giving you a whole lot of different informations. और अपने को क्या करना है, we have to check which of the informations are correct and which of them are wrong, and finally give the answer for the incorrect one. But that is where observation helps us sometimes. Okay. So if you just look at this question directly before you come to the option, observation helps you understand that the vector B is nothing but twice of vector A. You see that's happening. So the vector is twice of A. What all it means? It means that magnitude of B is equal to 2 times magnitude of A. Okay. And then it also means that B is parallel to A, which means that the angle between them is 0. So once two vectors are parallel, it also means that A dot B will be just AB because cos theta is unit. So all these things you understand becomes correct. So from that you can see that option A given is a correct option. Option B given is a correct option. Option C given is also a correct option because you can see that mod A is 5. But option D given will become the wrong option. So this is the one you have to mark. You can also see from this that magnitude of A is 5 and magnitude of B is 10. So just the observation of this fact here would have made life much easier, because then directly you can see A, B, C are correct and B is wrong. ये observation अगर नहीं किया होता पहले तो क्या करना पड़ता? We would have had to actually check each of the options. So hope you are getting my point, all of you, from this. Yeah, Mehak, I will come to question 13, don't worry. And I'll also come to question 8, Ayush. But hope now 4th, 5th and 6th question is clear to all. Acha, Sarvesh, you want to understand 5th question again? Just a moment. 5th question mein kya hai? See, Sarvesh, it's given to us that 3 forces are perpendicular to each other. Okay. And their magnitudes are 3, 4 and 12. And we have to find the resultant force's magnitude. So if they are perpendicular to each other, they are mutually perpendicular. That means we can take them to be along x, y and z axis respectively. We can define our x, y, z axis such that they are perpendicular. Okay. I mean such that they are along the forces F1, F2 and F3. So F1, F2 and F3 become like this. So what about the resultant force then? The resultant force, which is F1 plus F2 plus F3, just that will become, just add the 3 vectors. So 3i cap plus 4j cap plus 12k cap. So this becomes your resultant. So now magnitude of the resultant just becomes by this formula, root of x component square plus y component square plus z. ऐसे करना है, ठीक है? Okay. And 6th I hope is clear to all of you now. Let's come to 7th question. So in 7, 2 vectors are given to you, and it is asked the condition for them to be perpendicular to each other. Okay? So question 7 is basically about this. I'll tell you how to work it out. Then you can even try yourself just now. Okay. If 2 vectors A and B are perpendicular, what it means that their dot product should be 0. No, because recall cos 90 is 0. So A dot B for 2 perpendicular vectors will become EV cos 90. That will become 0. Okay. So that's very easy. Now if you know the 2 vectors in component form, it means product of x components plus product of y components plus product of z components should be 0. This is a condition. This is condition for perpendicular vectors. So apply this now in 7th question. Okay, so in 7th question, the vectors are given to us as some unknown constant C I cap minus 4j cap plus 2k cap. And similarly, the vector B is given as 2i cap plus 4j cap plus the same unknown C times k cap. Now we want to find C if A is perpendicular to B. You just apply this condition. You will get the answer. अगर दोनों वेक्टर A and B perpendicular है, their dot product should be 0. Now their dot product will become what? Ax into bx, which is C into 2 plus ay by, so that's minus 16 plus az bz, so that's 2c. So you'll get a simple linear equation in C. Okay, so done this question, people. Just apply this condition now. So here you can see that A dot B is AX into BX, so that is 2C, plus AY into BY, so that is minus 60, plus AZ into BZ, so that's again 2C, should be 0 for theta to be 90 degrees. So there you are. So you can see from this we are getting C is becoming how much? 4. That should be the answer. Okay. Now, eighth question, it just looks complicated. It's not very difficult. Hope this is clear to all of you, first of all. Okay. So good. All of you got this correct. Austin, Yashmit, Tanish, Nasit, Vashisht, Mehak, Aban. Good. Okay. Now just go through the eighth question. I'll explain first of all what you have to do. So eighth question में देखो क्या दिया हुआ है. Two vectors are given to me, A and B, and we have to find a unit vector which is perpendicular to the resultant of A and B. So यही perpendicular condition ही use करना है. What we have used in the seventh question, but with respect to what? The resultant of two vectors A and B, not with respect to A alone or B alone. Okay. So in eighth question, given vector E as something and vector B as something. So E is 8 I cap minus 6 j cap. And vector B is 8 I cap plus 8 j cap. Now we have to see that which of these is a unit vector perpendicular to the resultant of A and B. So first of all, let's find this resultant. So that is becoming how much? That is becoming 16 I cap plus 2 j cap. This is the resultant. Now, given these options, so इसको back calculate करना पड़ेगा. Okay. Is n cap so So option A is this unit vector I cap minus 8j cap divided by 65. So first of all, we have to do is what we have to check if the given vector is a unit vector. It is asking very clearly ना कि unit vector चाहिए मुझे जो कि इसके perpendicular है. So this vector, you have to first see is it a unit vector. So just check what is its magnitude. Magnitude of I cap minus 8j cap divided by 65 is square root of 1 square plus 8 square divided by 65. So it is root 65 by 65. It is not, in fact, okay, it is incorrect. It is 1 by root 65, which is not 1. Okay, so that means this thing has failed. It is not a unit vector. Okay. So you can rule out option A that way. That option A is wrong because the given vector is not a unit vector. Now let's come to option B. Option B में क्या किया है? It's given as I cap plus 8j cap divided by root 65. So first of all, let's check, is it a unit vector? And the answer to that is yes. We just saw, okay, because mod of I cap plus 8j cap divided by root 65 will become mod of I cap plus 8j cap, the whole thing divided by root 65. And we just saw that this is root 65, which is equal to unity. So that's okay. Okay. So that's the first thing. That is it a unit vector? Yes, the answer is yes. Now next thing is it perpendicular to that resultant? So for that, this unit vector's dot product with the resultant should be how much? 0. So just check. So the unit vector given to us is I cap plus 8j cap divided by root 65. And the resultant we had calculated, go back there, was 16 I cap plus 2j cap. यही था ना resultant. You can see, so dot product is not 0. Both the components are positive now. So it is 16 plus 16 divided by root 65. 32 by root 65. So therefore they are not perpendicular. Therefore n cap is not perpendicular. So let's come to option 3 now. In option C, the given vector is I cap minus 8j cap divided by root 65. So let's check this. First of all, we can see that mod of I cap minus 8j cap divided by root 65 is 1. So yes, it is a unit vector. The first point. The second point, is it perpendicular to the resultant vector? So for that, you again quickly check that n cap dot r, how much that is. Okay. So now if you check n cap dot r cap, you will see that in this case it is 0. So they are perpendicular. Why they are 0 now? Just check. This is your n cap. It is 1 by root 65 into I cap minus 8j cap. And what was your resultant vector there? It was 16 I cap plus 2j cap. So n cap dot r cap, or r rather, is becoming how much? 1 by root 65, this is a constant, I cap dot 16 I cap, that is 16, minus 8 j cap plus 2, so that's minus 16. So it's you can see that both the conditions are satisfied. So therefore your answer should become C. So this question we have to do as an indirect question. Okay? We have to look at the options and check two things. In the options we have to check each option. Check first of all, is the given vector a unit vector? So its mod should be equal to unity. Okay. And second, is it perpendicular to the resultant? So for that, n cap dot r cap or r should be 0. So check this. So these are the two checkpoints that we have to do at each of the options, and that's how we have done each of them. No, Raj, hope you have now understood. Unit vector does not mean I cap plus j cap. I cap plus j cap is not a unit vector. I cap plus j cap has a magnitude of root 2. Okay, unit vector means such a vector whose magnitude is 1. Standard unit vectors are I, j and k, but any unit vector in general is a vector which has magnitude of unity. Yeah, so Sarvesh, to answer your question that if they are not perpendicular, then we will not select that option. No? Because question में पूछा क्या है that which of these unit vectors are perpendicular. So Aditya, in this question we will not be able to use the cross product because cross product का थोड़ा different result होता है. It gives us a unit vector which is perpendicular to both the vectors A and B, not perpendicular to the resultant. Okay. So when we come to cross product, you will understand why it is. Yeah, exactly, Sarvesh. That's correct what you said. Okay. Right. So let's. Does anybody have a doubt in question 9, 9 and 10? Okay, good. So I think 9 and 10 everybody has got correct. Yes, I'm coming to 13. Okay. So what about 11th question? Samarth has asked for 12th question, so I'm going to do 12th next. Does anybody have a doubt in the 11th question? 9, 10th and 11th, anybody has a doubt? No, good. So then we'll do 12th and 13th. Okay. So 9, 10th and 11th are direct questions. Okay, please try them out yourself in case you haven't and discuss with me. Okay, later. Now let's come to question 12. So in question 12, it is given to us that A dot B is equal to minus 20. Now that also tells us that the angle between them must be obtuse. Okay. And magnitude of A is 4 and magnitude of B is 5. Now from this we have to find mod of A plus B. So if you recall in triangle law, for mod of A plus B, we need what? We don't need their magnitudes, which are given. Okay. And we need also theta, the angle between them, which is indirectly given. Okay. So since E dot B is equal to AB cos theta, here you can see that 4 into 5 into cos theta is equal to minus 20 is showing you that cos theta is minus 1 or that theta is equal to 180 degrees. Therefore, magnitude of A plus B will here just become mod of A minus 1 because theta is 180 degrees. You can use this directly. So that is 1. Okay. Or you can just substitute in the formula. But that's unnecessary. यहाँ पे इतना लंबा करने की जरूरत नहीं है. Because you can directly see theta is 180. So you can also do it this way. That is root of A square plus B square plus 2AB cos theta. Now in this you substitute that cos theta is minus 1, mod A is 4, mod B is 5. So you get the answer. This is 1. Okay. But such a lengthy substitution is not required here, as I said, because directly you can use the property of anti-parallel vectors. The moment you see that this dot product is telling you that cos theta is minus 1, you know that they are anti-parallel vectors. A and B are anti-parallel. Okay. And anti-parallel के properties क्या होते थे? That the sum of their magnitudes, I mean the magnitude of their sum resultant is actually the difference. We make use of that. Alright, so that's the 12th question for you people. Just minimizing this so that you can see the second thing also. Okay, now next let's come to the 13th question. Okay, Vedant, I'll just tell you the method of doing the 11th question. Direction cosines दिया है ना मुझे cos alpha, cos beta और cos gamma and magnitude of the vector is 65. So given the direction cosines, question 11, cos alpha, cos beta, cos gamma is given and magnitude of the vector is given. So now how to find the components? Just use the formula of direction cosine. Okay. Therefore, x component will become how much? Cos alpha into mod A. Y component will become cos beta into mod A, because that was the definition of direction cosine. No? So इसको invert कर दो, like that Az become cos gamma into mod A. So now just substitute the values, you'll get the components. All right, let's come to 13th question. Okay, so it is given to us that A plus B is perpendicular to A minus B. And mod A is equal to 5. So mod B we have to find out. The magnitude of the vector B we have to find out. Okay. Now this question I will show you by number of different methods today. Okay. The first method we'll see is what we've just done recently, using dot product. Okay. So if any vector A plus B is perpendicular to any other vector A minus B. In terms of dot product, it means that scalar product should be 0. Okay. So here we are using that property, that dot product of perpendicular vectors is 0. Making use of that property. Now next thing, use the distributive property. So A dot A minus A dot B plus B dot A minus B dot B is equal to 0. So in this step, I made use of distributive property of dot product, which you are seeing. Okay. Now next step, A dot A is nothing but magnitude of A square. Okay. And A dot B is the same thing as B dot A. Okay. So here I am making use of the property that one is that, and also I'm making use of commutative property. Commutative property क्या है? That B dot A is equal to A dot B. This property, that B dot A is the same thing as A dot B. So now this and this cancels. So if the whole thing is 0, the condition is now that A square minus B square is 0. Okay. So that means A minus B into A plus B is equal to 0. Now A and B are both positive because they are magnitudes of vectors. Okay. So therefore A must be equal to B. A cannot be equal to minus B. So this bracket only must be 0. So magnitude of vector A must be equal to magnitude of vector B, which must be 5. So this is a fairly important thing. I'm just minimizing this and showing you the whole thing now. How we are making use of scalar product for perpendicular condition of two vectors. In this case, the two vectors we are applying the condition to happen to be the sum of two vectors and the difference of two vectors. Okay? So we have said that, okay, if their resultant and their difference are perpendicular, then unka dot product 0 hona chahiye. Then open this dot product by distributive property. Then in that express the fact that B dot A is the same thing as A dot B. So the middle term becomes minus A dot B plus of A dot B. So these two terms cancel. And the first and the last term are A dot A, which is A square, and B dot B, which is B square. So we get the condition that A square is equal to B square. That means in general A should be plus minus B, but here they can only have a positive relationship because they are both magnitudes. So this is one of the critical questions in this. So hope this question is fully clear, people. Okay, so this is clear to all. Yes, Kashish, I have taken Nilay back into the meeting. He has got logged out. Thanks for informing me. So I think everybody is back in the meeting now. Now, Piyush, the thing is, you have to understand, here it's dot product of vectors. You cannot treat them like a scalar operation like you're doing. Okay? You cannot replace vector A plus vector B as mod A plus B. You have to understand that thing. I cannot write this as 5 plus B as a scalar sum. It is a vector sum of A and B. So you have to do these steps which I've shown you. Service buffer classes, I'm not exactly aware of what you are talking about. You can just ask Rahul sir or Gyaneshwar sir once, they will tell you. Right, so this was one method. Now let's look at another interesting method of doing this. Now method 2 is a geometrical method. Now see, geometrically when we discuss about two vectors and there's sum and difference. So kaisa hota hai, if the two vectors are making some kind of angle with each other and we draw the vector parallelogram. So these two vectors are E and B and the angle between them is some theta. So this becomes a vector parallelogram. Now in this, you know that the sum of A and B is this diagonal. And the difference of A and B is this diagonal. So this is A minus B. And this is A plus B. Okay. So you can see that within the vector parallelogram, in the parallelogram form with E and B, okay, if A plus B is perpendicular to A minus B, then that implies that diagonals are perpendicular. Okay. Now, what kind of a parallelogram has perpendicular diagonals? Only when it is a rhombus. So, this condition, it now implies that the parallelogram is in fact a rhombus, equal sides. So magnitude of A is equal to magnitude of. So the condition for this angle here to be 90 degrees is that these sides must be equal. So mod A must be equal to mod B. So you can use the property of rhombus and understand this. The important property of rhombus here is for a rhombus, the diagonals bisect perpendicularly. So making use of this property over here when we are doing the geometrical solution of this. Okay. So I'll just leave you with a bit of time to go through both these solutions. Now there is yet one more interesting way of solving this also, and I will discuss that with you. Okay. तो यहाँ पे दिया हुआ है that a plus b and a minus b are perpendicular to each other. We can also make use of component method. Think after completing this one, the method to writing it down. Think how we can make use of component algebra. Okay, students, so hope this is clear. And have you thought about the next method? using component algebra, very good. I think you've done very good. Correct, that is the correct method. So using component algebra, what you can do is E plus B is perpendicular to A minus B. Okay. That is the given condition. So assume E plus B is equal to some unknown x I cap and A minus B is some unknown y j cap. These two assumptions. Now solve to find vectors A and B and then show that magnitude of A will become equal to magnitude of B. Okay. So this is the method for doing it, and we have discussed this kind of thing before also, and you'll see that it's quite easy to do. So this is the third method. Right, so that's the 13th question in all the parts, I mean all the methods. Let's come to 14th and 15th. So they are fairly easy questions, but anyhow, let's quickly go through them. So question 14 says we have two unit vectors which are at an angle of 127. So let's say unit vector A and unit vector B. So A cap and B cap are at theta equal to 127 degrees. So you have to find their dot product. So dot product of two unit vectors just becomes cos theta, because as you know, the magnitude of one vector and the other vector is unity. So AB cos theta just becomes cos theta. So here that is cos 127 degrees, that is minus cos 53 degrees, that is minus 3 by 5. Okay. So as I said, fairly straightforward question. So these are the unit vectors we're talking about. Unit vectors A cap and B cap, let's say, are at 127 degrees. So their scalar product becomes this much. Okay, let's move on to the final question of the worksheet. So in this, it is given that the sum of two vectors has the same magnitude as the difference. So from that, what we can say about A dot B. Okay. So here you can see that this happens when cos theta is 0 or theta is 90 degrees. So when that happens, what happens to dot product? It becomes 0. So it's simple. So even mod A and mod B's value is not required. Number of ways to remember this. Okay. Diagonals are equal for a parallelogram only if it is a rectangle. or square for that matter. But importantly, theta is equal to 90 degrees. So that is the direct condition. You can just understand it that way only. Still, to answer your question, the dot product of unit vectors isn't zero in that case, in the question number 14, because the angle between them is not 90 beta. The angle between them is something else. It's 127. Agar I cap dot j cap hota hai, or something like that, where the angle between the two dot unit vectors is 90, only then their dot product is zero. Here they are two arbitrary unit vectors now, and arbitrary in the sense that the angle between them is given to us as 127. Yeah, in question 13 beta, you'll get this. You just try this now. You add the 2 and you'll get the value of E. So when you solve this now, you'll get the vector E as x I cap plus y j cap by 2. And you subtract the 2 and you'll get the value of vector B as x I cap minus y j cap whole by 2. And from this, you'll be able to now show that this is the case. We've done a few questions like this in the last worksheet also. Yes, Raj, this is the same question you are also asking, so I'm explaining. Okay, people, so that was about the discussion of the worksheet. Now we come to some more important applications of scalar product before we come to the final part of vectors, which is cross product. So now next we will see more about scalar product. Hey, Raj, that was the assumption. If you go back to that solution now when you're revising it, you see that based on the statement that a plus b and a minus b are perpendicular to each other, we made the assumption that let a plus b be along x-axis, then a minus b becomes along y-axis. X is an unknown, so it's just an assumption. It's not given in the question or something. Yes, Sarvesh, you have some doubt? Sarvesh, do you have any question? Okay, so let's come back to, okay, because you sent the question marks, so I was wondering. Anyway, so let's come back to this last part. Okay, no problem. Right, so let's come back to this last part. So more about scalar product. So let's understand this in this way. That if we have two vectors like this, such that the angle between them is theta. This is the vector E and this is the vector B. Now, E dot B, as a formula we have seen, is AB cos theta. But now you can see something interesting in this. Just a moment. Students have got logged out. Piyush and Anshuman, okay, they're back now. Still somebody got logged out. Yeah, Anshuman is here now. Right. So, again, 3 people have got.
Okay, so coming back to this, now in this you can see something interesting, that the quantity b cos theta, if you think about it, what this quantity is. So if you drop a perpendicular from B onto E like this, so you can see that this quantity here is nothing but B cos theta. So you can see that B cos theta is the component of the vector B that is parallel to E, or we can say it is the projection of the vector B along the vector B. Okay. So in other words, therefore, dot product of A and B, which is AB cos theta, can also be interpreted. So the interpretation of this is that A dot B is equal to the magnitude of A multiplied by the projection of B along A. Multiplied by the projection of the vector B along the vector B. Okay. So if this is some arbitrary vector A and this is some arbitrary vector B, then drop a perpendicular from B onto A like this, and now B will be making a projection which is along A, and that projection is your B cos theta. This projection is B cos theta. So that becomes magnitude of A multiplied with magnitude of B cos theta. So this is mod of vector A multiplied with projection of B along. Okay. So this becomes a useful and important aspect of what is dot product. Like we saw it as a formula last time. We know how to calculate dot product, but really dot product में क्या calculate करे? Like interpretation उसका क्या है? Physically what does it mean? What A dot B means? So it means the magnitude of one vector multiplied by the projection of the other vector along the first vector. So that is why, for example, we use it in the definition of work done. It is force multiplied by displacement's projection on the force. Okay. So that becomes the interpretation that the scalar product of two vectors is nothing but the magnitude of one vector, that is mod of A, multiplied by the projection or the component, okay, or the component of the second vector along the first, parallel to the first. That becomes the interpretation. Okay, let's understand this with a couple of numerical examples. So for example, if I have vector A of magnitude 20 vector B of magnitude 10 and theta is equal to 60 degrees. I ask you, what is the dot product of A and B? And secondly, I ask you, what is the projection of the vector B along the vector? So now you understand here what is happening is, if suppose this was my vector E, then my vector B will be somewhere here. Correct. True. The answer is correct. E's magnitude is 20. But more importantly, this angle theta is 60 degrees. So your first part's answer, E dot B, is EB cos theta. That is nothing but 20 into 10 into cos 60. So that's 100. But your second part's answer, what is the projection of the vector B along the vector E? The answer to that is, it is B cos theta, which can also be just written like this. It is A dot B upon mod A, because that's how A dot B is defined. Okay. So in the diagram, you can see that projection is, you have to drop this perpendicular from B onto A and find how much length it is cutting. So to drop a perpendicular here, you can see that this is the projection that we got. So this is that B cos theta. So how much is that now? That is 5. Whether you do it by this formula or you directly do it in the diagram, you can see that that will be equal to 5. Whether you write it as 10 cos 60, yeah, E dot B, which is 100 divided by mod A, which is 20, either way, in any case you can see it as 5. Okay, so hope this is fully clear. Yes, we can also see the projection of A along B, but that will become a different quantity. That will become A cos theta. That's the formula, ना बेटा? E dot B का formula क्या है? AB cos theta. So B cos theta कितना हो जाएगा? A dot B divided by, just transfer the A to this set. Now, just for reference here, in the same question, if we were to calculate, for example, now also we want to calculate, also find the projection of the vector E along the vector B. So now that thing's interpretation becomes different. Okay. So if our vector E was lying like this, and vector B was like this, theta was 60. Now what we are trying to find out is something different. This is the direction of vector B, and we have to drop a perpendicular from E onto B, not from B onto A, but E onto B, because E का projection निकालना है along B. So A से यहाँ एक perpendicular drop करना है. that perpendicular will look like this. Okay. So the projection of A along B will now become this one. So it doesn't matter that B is shorter in length. Okay. What is important is along A's direction, rather along B's direction, this is the component. So we have to find E cos theta, which can also again be written as A dot B divided by mod B this time. So whichever way we write it, we can see that here this is going to become 10 because magnitude of A was 20 and theta is 60. Oh, so this is actually exactly equal to. So anyway, that's just a matter of coincidence. ये दोनों vectors exactly equal magnitude हैं. It's just a matter of coincidence, but no, here I've just asked it in terms of a scalar quantity. E cos theta, you can see, is just a scalar. You don't have to give it any direction. Now let's see another example of this. The more important type of example, where the vectors are given in component form. Okay, so given vector E is equal to I cap plus J cap plus K cap, and vector B is given as 2I cap plus 2J cap. So you have to find the projection of E along B, just as a magnitude, like we've done above, and then the reverse of that, the projection of B along A. Just try this out now. Just apply this. That's the thing, ना, we don't know theta, but we know how to calculate dot product. तो यहाँ कैसे करेंगे? Formula से निकालेंगे. What is the projection of A along B? By the formula, it is E dot B divided by mod B. So we can find A dot B, no? We can find mod B, no? Like that. Okay, so in this question, we have to directly use, because we can't sit down to find theta and all that. Yes. You just check your calculation again. So here we'll find, for the first part, we want to find projection of A along B. So that is basically E cos theta. So now we won't sit down and calculate all these things. We will calculate, theta and all that. We'll just find this like this. Why? Because by definition, E dot B is AB cos theta. So I now want to find E cos theta. So just bring the B to this side. Just A dot B. Okay. Understood this now? The formula. Okay. Okay, so now see, given vector E was I cap plus j cap plus k cap, and vector B was 2 I cap plus 2 j cap. Therefore, E dot B कितना है? It is 2 plus 2 or 4, and mod B कितना है? So 2 root 2 or root 8. Okay. So therefore, E cos theta is becoming how much? It is becoming 4 by 2 root 2, or it's becoming root 2. So the answer is directly root 2. So this is the projection of the vector E along the vector. Okay, but just in terms of magnet. We'll also in a moment we'll see how to calculate it as a vector quantity. K cap कंसिडर किया ना पीयूष, अभी उसका z कंपोनेंट 0 है ना b का, तो जस्ट यूज द फॉर्मूला ax bx plus ay by plus az bz, उसमें bz ही 0 है. Yes, correct. No, beta Shravanya, just check your calculation again. Okay, E cos theta is E dot B divided by mod of B. So I have shown you here why E dot B's value is 4, because E dot B is what? Ex bx. ये value कितना है? It is Ex bx plus Ey by plus Ez bz. So its value is 2 plus 2 plus 0. That's 4. That's how we got this. So it's 4 by 2 root 2, which is nothing but root 2. Understood, na? मतलब 2 divided by root 2 is the same thing as root 2, na? 2 by root 2 is the same thing as root 2. Yes, yes, Ayusha, that's correct. Dhruv, it's correct. The second part you got. Shravya, root 2 by root 2 is root 2 into root 2 by root 2. So it's root 2. Understood, no? That's how we calculate. Yeah, no problem. So this is like, I think recently in maths also you have done surds and all, so it's a little bit like that. You're rationalizing the denominator basically. Okay, now let's quickly look at the other part. So we have to now find b cos theta, the second part. So that is b cos theta. So that is E dot B divided by mod A this time. Okay. So we'd seen that E dot B was 4.
But what about mod A? It's root 3. From this we had already seen A dot B was 4. But what about magnitude of A? It is root 3. You can see the root of 1 square plus root of x square plus y square plus z square. So what about this thing? Now substitute this here. So we'll get b cos theta is equal to 4 by 1. So this is projection of b along B. Now you can also rationalize this 4 root 3 by 3 if you want to, okay, or approximately 4 into 1.73 divided by 3. So that way also we can do it. Okay. But this is okay. You can leave the answer this way, no problem. Yes, Samar, what exactly is your doubt, beta? Samar, if you are, I'm not able to understand what doubt do you have. Just explain. Okay, now next up we will see how we can also find how to find. I'll explain. I'll explain. I've understood your question. How to find the projection of, let's say, a vector E along the vector B as a vector instead of just as a magnitude. Okay, how to find that? Okay. This time, let's just say I've shown the vector E over here, the vector B over here, and this angle is theta. Okay. Now the projection of vector E along B to drop this perpendicular and then express this thing as a vector over here. Right. So this thing when I express as a scalar quantity or just as a magnitude, you've seen that E cos theta is equal to E dot B divided by mod B. Okay. So what was this quantity? It was basically, this is the projection of E along B, but just as a magnitude. Now I want to express this as a vector. So how to express this as a vector? So now you can see that the projection of E along B as a vector has direction parallel to B and magnitude equal to A cos theta. So therefore, if you want to express it as a vector, it will become how much? As a vector, it becomes A cos theta into a unit vector along the vector. It becomes this. It becomes a magnitude into the unit vector which is along B. Why? Because it is parallel to that vector. So this is magnitude into this term now, which is the unit vector along the vector. Okay. So this is how we'll express it as a vector quantity. So just note this down first, and next we'll understand this as an example, as a numerical example, and it will become clear to you how it goes. Okay. So just start by writing this down, the heading. How to find the projection of a vector A along another vector B as a vector quantity. So for that projection, what we have to do is that the red colored arrow which I have shown, whose magnitude is A cos theta. Now we have to express that as a vector. तो उसको वेक्टर जैसे कैसे एक्सप्रेस करेंगे? It just becomes magnitude multiplied by a unit vector. But which unit vector? The same unit vector that B has, because it's along the direction of B. Okay. So just write down up to here, then I'll scroll down. Exactly. Saurabh, that's the correct thing you're saying. The unit vector gives it the direction, whereas A cos theta is its magnitude. Okay. So it's like now we are expressing it as a vector. So it's the magnitude of it, which is A cos theta, multiplied by the unit vector, which is giving it direction. So when we do this with an example, you will understand even better. Okay, so for example, let's take those same vectors which I have taken in the earlier one. E is I cap plus J cap plus K cap, and the vector B was 2I cap plus 2J cap. Now let us find the projection of E along B as a vector. Let's say that vector is C. So C is a vector which represents the projection of A along B. So what I mean here is that अगर ये मेरा vector B था and this was a vector E, so drop this perpendicular here. Now this vector that we are getting as a vector, this quantity is becoming C. So C is the projection of the vector E along the vector. Okay. So magnitude of C is how much? It is E cos theta, which should be E dot B divided by magnitude of B, which we had just calculated in the previous example. So that was how much? That was root 2. You remember that quantity was. But what about direction? So direction of C is given by B cap. That is a unit vector along B. So B cap is a unit vector along the vector B, which was 2I cap plus 2J cap. So how to find B cap? Divide the given vector B by its own magnitude. This is how we find a unit vector B cap along a given vector. This is the method of finding the unit vector. Okay, so that is nothing but 2 I cap plus 2 j cap divided by magnitude of the same. 2 I cap plus 2j cap. So that is nothing but 2 I cap plus 2j cap divided by 2 root 2. So that finally becomes how much? Cancel out the root 2's, the 2's. So that becomes 1 by root 2 I cap plus 1 by root 2 j cap. Or you can also take the 1 by root 2 common and write it as 1 by root 2 whole thing multiplied with I cap plus j cap. So this has become my B cap. Okay. This is the unit vector along the vector. So I'm just minimizing this part, go through the steps. So now we've come to the two individual things. We know that the magnitude of this vector C is root 2, and we know its direction is along this unit vector B cap. So the vector C itself will become how much? It will become its magnitude, which was A cos theta, multiplied by the unit vector, which was B cap. So A cos theta, which is the magnitude, you've seen as root 2. And B cap was how much? I cap plus j cap, the whole value. So this vector now becomes I cap plus j cap. This becomes the projection of the vector B, of the vector E along the vector B. Okay, so just make a note of this, people. So with this example, hopefully it is clear to you what we mean by expressing the projection as a vector quantity. It has to be given some direction. Its magnitude A cos theta we've already seen before. The magnitude is A dot B divided by mod B, which in this case came out to be root 2. But now how to give it direction? So the direction is by multiplying it with the proper unit vector, which is nothing but a unit vector which is along the vector B, which was 2 I cap plus 2j. So that unit vector B cap will become nothing but B vector divided by its own magnitude. So that is 2 I cap plus 2j cap divided by its own mod, that is mod of 2 I cap plus 2j. So that's how this becomes. So you can see this is like another application of dot product. We can use the dot product to find the projection of one vector along another vector. So that is the reason why we interpret the dot product like this. Someone to answer your question, we can interpret it in this way so that we can find the projection of one vector along another vector. Like later in physics, for example, if I ask you, find the projection of the gravitational force along the inclined plane, or find the projection of the magnetic force along the magnetic field, and you know these two things in vector form. So how you will find the projection? By interpreting the dot product lines. Okay, people, so hope this is all clear. So this is where we conclude today's lecture. Very important lecture, with especially the last part, the application of dot product in finding the projection of one vector along another. So make sure you revise the examples so that you will be able to do the worksheet which I'm sending you. And it's also now a very good time to do some additional questions from your module, especially with relation to the operations that we've done before this, before scalar product, just as a revision of the various type of things we've done, like addition, subtraction, application of parallelogram law, triangle inequalities, etc., things like that. You will find lots of questions in your mathematical tools for physics workbook or module, the PDF of which you have. And I will send you a list of questions also apart from a separate assignment. So assignment will be about the application of the things we've learned today. whereas the list of questions will be for previous things, which are for which you can do some revision and additional questions from the module. Okay, so that's it for today's lecture, people. All the best. Okay. No, there's no class for you for vectors this week. This was the only lecture. Okay. In case students have missed some class, they can attend the class which is going on in the Foundation Builder group. That is only for students who joined very late. So who might have missed the early part of vectors, they can